Hello everyone, and welcome back. It's great to be with you again. In our previous sessions, we've explored the applications we build and the data they rely on. But we've been missing a fundamental piece of the puzzle. How do all these systems, servers, and users actually communicate with each other, whether they're in the same room or on opposite sides of the world? Today, we're going to explore that invisible foundation. We're going to study the digital nervous system of a modern business, its computer network. Our focus is K16, fundamental computer networking concepts in relation to digital and technology solutions. For example, structure, cloud architecture, components, quality of service. Now, I know for many, networking can sound like a highly technical, specialist-only topic. My purpose today is to act as your translator and demystify it. We'll break it down using simple analogies and show you how this knowledge is absolutely critical for every role in technology, from software engineering to business analysis. By the end of this session, my objective is for you to feel confident explaining the core concepts of networking and, crucially, to know 3 simple, practical ways you can gather evidence about the network you use every day, ready for your portfolio and professional discussion. Let's get started. Before we dive in, let's build our scaffold. This KSB gives us 4 key areas to understand. Think of this as the map for our session. We'll tackle each one, step by step, so you can build your confidence. First, we'll look at structure. This is simply the layout of the network, like the map of a city's road system. How are all the devices physically and logically connected? Second, we'll cover components. These are the building blocks of the network. This includes the hardware, like routers and switches that act as traffic police, and the software, rules of the road, the protocols that all devices must follow to communicate. Third, we'll explore cloud architecture. This is the revolutionary, modern approach where, instead of building and owning your own expensive infrastructure, you rent it as a service from a massive global provider. Finally, we'll discuss quality of service, or QoS. This is the traffic management system. It's how we create a priority lane on our digital motorway to ensure that important, time-sensitive data, like a video call, doesn't get stuck in a traffic jam. A great question I often hear is, Sam, I'm going to be a software engineer, not a network engineer. Why do I need to know this? It's a fantastic question, and the answer is simple. In the 21st century, the network is the business. First, it enables modern work. The ability for you to work from home, to have this video call, to access cloud applications like Salesforce or Microsoft 365, all of it is 100% dependent on a stable, well-managed network. Second, it directly impacts user experience. Have you ever used an app that just felt slow? You might blame the developer, but often, the problem is the network. A slow network means a slow app, which leads to frustrated users. Third, it underpins security. The network is the main highway for cyber attackers. To defend your organization's data, you first have to understand the layout of the digital roads you're trying to protect. And finally, it drives growth. Modern cloud networking allows a 2-person startup to instantly access the same global, scalable, high-performance infrastructure as a company like Amazon or Google. This has completely changed the game, enabling rapid growth and innovation. Okay, let's start with the first step on our ladder, network structure. This is a very simple but critical concept. All networks can be broken down into 2 main types, a LAN or a WAN. A LAN, or local area network, connects devices within a single, small physical area. The Wi-Fi network in your home is a LAN. The network connecting all the computers, printers, and phones in your office building is also a LAN. A WAN, or wide area network, is what you use to connect multiple LANs together over a large geographical area. When your company's London office needs to share data with its New York office, it connects them using a WAN. A simple analogy is a road system. The LAN is the network of local streets inside a single town. The WAN is the motorway system that connects all the different towns. And the internet. It's just the largest, most public WAN in the world. So, we have our network of roads. Now, how does the data actually move around and get to the right place? It uses key components for direction and a common language to communicate. First, inside your LAN, you have a switch. Think of a switch as the local postman for a single street. It knows exactly which house, which computer, on that street to deliver a specific piece of mail to. Next, you have a router. A router is a more powerful device. It's like the main postal sorting office. Its job is to connect different networks together. It's the gateway that sits between your office LAN and the internet WAN. It makes the decision, does this piece of mail stay in the local town, or do I need to send it to another city? And what language does this mail use? It uses a set of rules, or protocols, called TCP, IP. This is the universal language of the internet. It's made of 2 parts. IP, the Internet Protocol, is the addressing system. Just as every house needs a unique postal address, every device on the internet needs a unique IP address. TCP, the Transmission Control Protocol, is the reliable delivery service. When you send a large email, TCP breaks it into hundreds of small, numbered pieces called packets. It sends them across the internet, and even if they take different routes, TCP at the other end will wait for them all to arrive, check that none are missing, and reassemble them in the correct order. It's a truly brilliant system. One of the most important concepts in all of modern technology is cloud architecture. So, what is the cloud? I'll tell you, it's not magic. It's just someone else's computer that you can access over the internet. The on-premise or old way was that every company had to buy its own physical servers, put them in a dedicated room or a cupboard, manage the power, the cooling, and the security, and hire a team to fix them when they broke. The cloud or new way is to rent all of that as a service. My favorite analogy is this: on-premise is like owning and maintaining your own complex, expensive power generator in your basement. Cloud is just plugging into the national grid and paying a simple bill for the electricity you actually use. This includes different models, from infrastructure as a service, renting the basic servers, to software as a service, which you all use every day. Microsoft 365, Google Docs, Salesforce, these are all cloud applications. This shift has completely changed how we build and deliver technology. Our final core concept is quality of service, or QoS. The principle here is simple: not all data is equally important, or at least, not all data is equally time-sensitive. A network is like a busy motorway. If you treat every vehicle the same, you get traffic jams. QoS is the set of techniques we use to create a priority lane for the most critical traffic. To do this, we manage a few key metrics. Latency is the delay, how long it takes one car to get from A to B. Jitter is the variation in that delay, which is what makes video calls stutter. And packet loss is the number of packets that just get lost along the way. Now, think about two types of traffic. A video call is like an ambulance. It is extremely sensitive to latency and jitter. Any delay makes the call freeze. A large file download, on the other hand, is like a heavy goods lorry. We want it to get there, but we don't really care if it takes an extra 5 minutes. QoS is how we configure the network to identify the ambulance traffic and give it the priority lane, ensuring it has a clear run, even when the rest of the motorway is congested. This knowledge is not just for one specialism. It's a fundamental literacy for all of you. For you, Liam, as our network engineer, this is your world. You are the master of these concepts. But your challenge is to not just be comfortable with the physical hardware. Your growth lies in mastering the new networking, cloud architecture, and network automation. This KSB is your solid foundation to build upon. For Maya, our cybersecurity analyst, the network is your battlefield. You cannot defend a city if you do not understand its layout. You must understand TCP, iodine monophosphide, to analyze malicious traffic. You must understand the components like routers and firewalls because those are your defense points. And for Chloe, our software engineer, your code does not run in a vacuum, it runs on this network. When you understand latency, you can write more efficient code that feels fast. When you understand cloud architecture, you can build applications that can scale to serve millions of users, which is exactly what you're aspiring to do. Let's continue, because this is just as vital for our other pathways. For Ben, as our data analyst, you are constantly pulling large datasets across the network. If a query to a database in the cloud is taking a long time, how do you know if the problem is the database or the network? This knowledge gives you a logical framework to help troubleshoot and identify the real problem, which is a great way to reduce that feeling of ambiguity. For Tom, our business analyst, this is critical for writing good requirements. When a stakeholder asks for a new video conferencing feature, you can now be the person who asks, "Great." To ensure a good user experience, we must add a non-functional requirement for a cost policy. That is a high-level, valuable contribution. And for Aisha, our IT consultant, this is your language of strategy. Your clients are asking, should we move to the cloud? Understanding the difference between on-premise and cloud isn't just technical, it's a conversation about cost, scalability, and business agility. This knowledge is how you build trust and provide real value. Okay, let's talk about how you get the marks for this. This is a critical point, so please listen closely. K16 is a core knowledge topic assessed in your final professional discussion, which is all based on the evidence in your portfolio. It is not assessed in your major project. So, what you need is not a huge project, but a few simple, tangible pieces of evidence that you can use as talking points to prove you understand these concepts. Here are 3 simple actions any of you can take. First, Action 1, find your address. Find your computer's IP address. On Windows, open Command Prompt and type !IP config For your portfolio, explain what an IP address is and document yours. Second, Action 2, test latency. In that same command prompt, type --ping google.com. Your computer will send a few packets to Google and measure the reply time. This is your latency. Take a screenshot and write a reflection explaining what that time equals value means. Third, Action 3, identify architecture. Ask a simple question to your manager or someone in IT. For my apprenticeship, I'm learning about network architecture. Do we primarily use our own on-premise servers, or are we on a cloud platform like AWS or Azure? Then, write a short reflection on their answer and why you think your company made that choice. That's it. Simple, powerful evidence. Let's do a quick recap. Today, we have pulled back the curtain on the invisible world of computer networking. We've learned that it's not magic, but a logical, digital nervous system that forms the foundation for everything we do. We've seen the core concepts, the structure of LANs and WANs, the components and the language of TCP, IP, the massive shift to cloud architecture, and the importance of quality of service for user experience. And we've translated all of it with simple analogies. Your mission for this week is simple. Just pick one of the actions from the last slide. Spend 10 minutes being a network detective. Find your IP address, run a ping test, or ask about your cloud strategy. That's it. This knowledge is the perfect foundation for our next session on K17, where we'll learn about reporting techniques. We'll explore how to take complex technical topics, just like this one, and communicate them clearly and effectively. Thank you for your excellent focus today. You've learned the principles of the invisible infrastructure that connects our world. Well done.